Okay, it looks like everything's set up and ready to go. So let's get the webinar underway. Hello and welcome to the webinar today. On behalf of Digistore, I want to thank you for taking your time out of your schedules to be with us. My name is Mark Richards and I'm the Marketing Manager for Digistore. We're excited to be able to bring you this webinar today, but before we get underway, I'll cover off a couple of items of housekeeping so you can get the most out of the webinar. First off, Q&A. Throughout the webinar, we encourage you to submit questions via the Q&A. Click the Q&A button at the bottom of your Zoom window on your screen and type your question. Please use the Q&A button and not the chat function. At an appropriate time, we'll answer the questions either verbally or type an answer. Once the question's answered, it'll be viewable by all participants. If we don't get to answer your questions during the presentations, we'll get to them in the Q&A session at the end. Questions are also recorded, so we will definitely get back to you directly after the event for any questions not answered or needing further follow-up. If everything works as planned, the webinar will be recorded and a link to the on-demand viewing will be sent to everyone once we've prepared and uploaded the video. So first off, let me introduce Digistore. Last year marked Digistore's 30th year in business. Like many of us, late 2020 and 21 brought Digistore some unique challenges and surprises, which have resulted in new ways of working and living and new technologies to address these. These new developments were in some cases whole new ideas, and in some cases a dramatic acceleration in take-up and improvement of existing technologies. Production and post-production teams have been flung into remote working models and audiences have had to be reached in new ways and via new channels. It's been an exciting time for Digistore as we've navigated these developments to provide new solutions offerings for our customers and as we've welcomed new customers operating in ways that had not previously been possible. This webinar explores some of these developments. In the beginning, Digistore worked with video production and post-production professionals and helped them to utilize new and emerging technologies. Over time, and as Digistore's size, skills, expertise, and vendor relationships have expanded, we now address a wide range of application areas across many industries. I've summarized on this slide some of the areas we address around remote and live production, which would be relevant to the audience attending today, but it's just the tip of the iceberg. I'd encourage you to get in touch with us to discuss any technology or technical service questions you have, whether it's how do I manage my remote production teams, or what's the best way to implement live production and delivery, or anything else. We're here to help. Digistore works with a range of leading vendors. Our close working relationship with vendor partners means that we can utilize the vendor staff and resources to work with us on solutions for your needs. Here are just a few of the relevant vendors that we work with. Of course, we can't answer all of the questions or address all of your specific workflows and requirements in this session. So I'd encourage you to contact your Digistore account manager or Digistore generally so that we can help. Here are our main contact and communication channel details, but you will also have my email address from your webinar registration and reminder emails, so feel free to contact me directly at any time. Look out for our webinar follow-up email with further information as well as the recording link. Okay, let's get the show on the road. I'd like to introduce our presenter, Digistore Managing Director, Andrew Mooney. Andrew founded Digistore in 1990. His experience designing and installing, installing and maintaining services for broadcasters and post-production houses had made it clear to him at the time that the industry needed a group of experts who could look at things objectively and independently. The result is a company he's led for over 30 years that has been providing elegant solutions to leading organizations in the most technically demanding application areas. Andrew has been ably assisted with technical diagrams and product integration information by Digistore senior engineer Edward Shen. Edward's knowledge of network technology and how it is applied to media content and distribution has seen him develop and implement highly successful workflows for Digistor's clients. He has many accreditation from Cisco, Peplink, Dell, Avid, and others, and holds a Master's Science Internet Working Master's degree from University of Technology. Over to you, Andrew.
Okay, thanks for the great introduction, Mark. Today I'll be talking about workflows and technology for live and remote production. And as Mark mentioned, we can't cover everything today, so I'm going to focus on 3 popular use cases. Yep. We'll look at some of the technologies and products in use today for these applications using standard internet connections, not dedicated lines. Let me switch over the presentation and get underway. Okay, as I mentioned today, we'll be talking about 3 common use cases. The first of which is monitoring live video from a remote location. So this is where you have a live video feed in one particular location and you're wanting to view that in a secondary location. Second use case we'll be talking about today is remote production of live events. And this is where you may have multiple cameras or multiple feeds in one location and your production team and resources are in a secondary location. The third use case looks at using the cloud for the live production. We're also going to talk about the use of bonded cellular technology and full turnkey solutions. So I'm going to step through each use case and give you an overview of what's possible. I won't be talking about specific model and part numbers, but I will be highlighting encoders and decoders from KillerView, who offer a good range of cost-effective products. I'll also be highlighting routers from Peplink, and for fully integrated systems, I'll be talking about products from Digistor. Also note that many of the products I'll mention today are very cost-effective and available on our website. So for some of you, the next steps might be as simple as heading to the website and getting started straight away. These use cases can use standard internet connections. And some people may ask, can you use standard internet connections, sometimes called the open internet, to reliably deliver high quality video? Well, the answer is yes, but traditionally this has been problematic. The internet was not really designed for the delivery of live video signals, but more for the transfer of data. Video needs reliable in-sequence delivery of video frames. And some of the challenges with the open internet are jitter and packet loss, corrupt or out of sequence packets, latency and network congestion. And I think we've all seen results of poor video delivery over the internet. So some new protocols have been developed in recent years to overcome these challenges and enable reliable delivery of high quality video signals over the open internet. 2 of the most popular protocols are Srt and Zixi. There are also a number of others, including Caton's R2TP, but certainly Srt and Zixi are the most popular. These protocols deal with the challenges mentioned prior and enable that reliable delivery of high quality broadcast video over open internet. So let's talk about each one. Srt was originally developed by Haivision. It's now an open source protocol. So lots of manufacturers now integrate Srt into their products. It's very popular these days. Zixi is a proprietary protocol. It's more powerful feature set and ecosystem than Srt. It allows for multiple redundant paths and lots of other cool features. More suited to complex applications and quite popular in broadcast applications. So lots of manufacturers have Srt built into their encoders and decoders. However, Srt and Zixi can be used with most encoders, even if it's not built in. So let's have a look at the first use case, remote monitoring. So we have a diagram here of a typical remote monitoring application. It's fairly simple. It's a point-to-point delivery of one or more video signals, as opposed to streaming application to multiple viewers. Now, having said that, The KillerView encoders shown in this diagram can also stream to common CDNs like Facebook Live, YouTube, Vimeo, etc. So this remote monitoring application is where a video signal or a video feed is sent from one location, sent over the open internet to a secondary location. Typical applications might include the real-time monitoring of an editing session. So you may have a producer or someone else in a secondary location that needs to view the edit as it's underway. It might be delivering a church service or a town hall type meeting to a secondary venue. It could be, even in the medical side, it could be a medical procedure that's underway that's being filmed live within a hospital, for instance, and that being sent to a secondary remote location, perhaps for training other doctors and perhaps on a large screen. Monitoring CCTV or multiple CCTV security cameras is also an application. So pretty much any application where a live video feed needs to be sent to another location. So, you know, just note this is quite a basic setup and it's relatively low cost. So let me just quickly talk through this. So on the side here, we have our camera or our video feed, which is being fed into an encoder. In this case, we're showing a KillerView encoder. We're then using, that's just plugging into a normal internet connection, and it's using this SRT protocol to enable that reliable delivery of the video signal over the open internet. Then at a secondary location, there's a decoder that plugs in and basically brings that signal back to either HDMI or SDI. So we're showing the KillerView encoders here as mentioned. It could be products from other manufacturers, and certainly Digistor has access to a wide range of encoders and decoders to suit pretty much any application. Just from a cost point of view, the KillerView encoders, you're looking about $600 for an encoder and around $1,000 for a decoder. The price point can go up to $5,000 or more for higher end products. So with this particular setup, we can set what's called the bit rate to suit the application and the internet connection. So if you have a high speed internet connection and you're looking for a high quality image, perhaps for projection on a large screen or critical viewing, you might go with 10 to 20 megabit bit rate. On the other hand, if you have a slower internet connection and or a lower picture quality is acceptable, then maybe it's around 0.5 megabit to 3 megabit. So you have sort of certain configuration options, I suppose, available depending on the application. We're also showing here, in this application anyway, the use of a fixed internet. So simply the encoder plugs into your home internet or your corporate network, and the decoder plugs in at the other end. So it's pretty straightforward. And I suppose it's worth noting that these encoders typically have more features available. So let's just quickly touch on those. From an encoder point of view, it's certainly with the KillerView encoders and other encoders as well. Typically, they have other features. In the case of the KillerView, you've got the ability to add graphics or text overlays on the video input as it's coming in. You can do some image manipulation, cropping and rotation. You also have the ability to record locally onto either an SD card, USB stick, or a NAS device. You also have the ability to stream to Facebook, YouTube, etc., as I mentioned earlier. From a decoder point of view, some of the additional features you might see is the ability to decode multiple streams, so have multiple outputs on your decoder, perhaps dual video outputs, for instance, and even multi-viewer applications where you might be able to decode up to 16 streams and show them on a large screen. So to give you a little bit of an idea about the physical aspects of how big are these things, we're going to switch to a secondary camera here and have a quick look at the encoder. So it's coming up now, where it should be. There we go. So this is the KillerView encoder. This particular one is an HDMI unit. It's very, very compact, as you can see. It's quite a small unit. It has an HDMI input and an HDMI loop through. You can see the Ethernet connection there, so that's where you would plug it into your corporate network or your the network that you're wanting to stream onto. On the other side of the encoder, you'll notice it has a, it's a bit hard to see, but you have a slot there for a SD card, and there's also a couple of USB things there for local record. So it's a very, very compact unit, quite straightforward, and just give you a bit of an idea about the physical size of the unit. I'll go back to talk about the next use case. Okay, let's move on to the secondary use case. Okay, this is remote production of live events. So it's very, very similar to the remote monitoring application, but it's quite different. It's still fairly simple. It's a point-to-point scenario. And once again, we're using the open internet to deliver multiple cameras streams from the event to the production room or the production hub. So in this case, we're showing 4 cameras at the event, and we're showing those going into a 4-input encoder and feeding those to the production hub. So I suppose what's important to note here is this is where the cameras are in a different remote location to the production control room and the production team. So the 2 sites are connected to the internet, but could be in different cities or potentially even different countries. And this sort of remote production model is increasingly being used to keep production costs down by reducing the number of people required on location or where the event is happening. So traditionally, an OB van or a whole lot of equipment would need to be driven to the venue. The cameras would need to plug into that. The production team would then need to travel to the venue, and they would produce the show inside the OB van with the video output then being distributed to the appropriate channel, be it terrestrial TV, streaming, YouTube, etc. So this involved considerable travel expenses, not only to fly camera operators, but the entire production team to the venue. And when the event was over, the team would need to fly back to their home base, and the OB van would need to drive to the next location. So you can see a lot of time and expense was spent traveling. So the diagram above is the depiction is quite simple. It's very, very simple. Quite often it may be a lot more complicated than this. And for a live production, generally there's a need to send other signals from the location back to the production hub and from the production hub back to the live event. So let's just take a little bit more, a slightly more complex look. So here we're seeing a similar diagram, but now we've introduced a couple of routers, a router at each end. So this establishes a what's called an SD-WAN between both sites. And once again, with the right technology, this can be done over the open internet. So now you can send signals each way, like comms, talkback, tellies, return video, etc. And for larger events, as you can imagine, this can get quite complex. This newer remote production model means that only the camera operators and a small skeleton crew need to travel to the venue, and the production team and all the production equipment, vision mixers, slow-mo replays, graphics, etc., operate from a production hub at their home base. So there's significant cost savings in this model, and the production team can produce more events each week with less time spent driving OB vans around and flying in and out. So as with remote monitoring, remote production that makes use of lower cost encoders with Zixi or SRT, for example, and using the open internet to deliver those signals provides a very cost-effective model. And I suppose this has resulted in the ability to cover lower tier live sporting events, reaching new audiences and new markets. But it's not only for sporting events, it's for any live production. So it could be any application where you've got multiple cameras feeding back. Important to note also is this is how most main sporting events are being covered in Australia today. Think your big NRL matches, your AFL matches. Obviously, these are very high profile events, and the setup is a lot more complex than what we're talking about today, but it's a similar sort of concept. And once again, from a costing point of view, we're looking at around $600 for each encoder, around that $900, $1,000 mark for a decoder, and then routers probably start at around $2,000 each. So quite cost effective. The third use case is where the production equipment is now in the cloud. So this is similar to the remote production model, but now the live switching, etc. is done in the cloud. And this model became more popular during the pandemic, especially overseas, as lockdowns prevented production people traveling to the production hub. And now they needed to produce the show or the event or whatever it was from their home. And certainly vMix has proven quite popular in this application. So what we've got here is the live event side looks pretty much the same. We've got the cameras going into an encoder, but this time the feeds are directed up to the cloud using SRT to a production environment within the cloud. In this case, we're showing a simple vMix system. And then the operators would be controlling that at a remote location, perhaps at their home, using a Digistor technology, Digistor client or Digistor 0 client, which enables that. And here's a photo here of, there were some great photos on LinkedIn during the height of the pandemic with people's home setups. So vMix operates on a subscription model and can be used either on-prem or in the cloud. So we've covered here 3 typical use cases. And each of these have assumed that there was a fixed internet connection available at location. But what if there's no internet available? Can we use 4G or 5G? People say, well, the answer is definitely yes. A very simple solution might be to use a single 4G modem, but this is obviously not very reliable. So most people would use what's called bonded cellular, and this is where multiple cellular connections, say 4G connections, are joined together to create a more robust connection. So this diagram above shows a very simple setup where a single encoder here feeds a router that has 2 4G connections on it, which are bonded together. So the signal is then received by the decoder and turned back to SDI or HDMI. So let's just quickly talk about bonding and what that is. Bonded cellular, it's where 2 or more cellular connections, and typically these days it's still 4G in Australia. It gives a more stable, resilient than a single cellular connection. You can also introduce carrier diversity by having, for instance, if you have just 2 modems, you might use Telstra SIM in one, and you might use maybe an Optus or a Voda in the second. It certainly gives you a higher speed connection. It's not uncommon for people to use systems with 4 or more bonded cellular connections. And a simple modem, a dual modem router like this, like the Peplik one shown, around about $1,500, and you just add your own SIM cards. And it's a great low-cost setup using a separate encoder to deliver the live feed. We do have a camera on that as well, so we'll just take a quick look at that before we move on to talk about a fully integrated solution. So the camera's just coming up. Okay, so this is the Peplink device we talked about. This is one that includes 2 4G modems internally. We can see it has the antennas on the back of it. It also has slots available. You probably can't see, but there's slots there available for the SIM cards to go in. And then on the front of the unit, there's simply a LAN connection where you would plug your encoder into, and it's DC powered as well, so you can use that in a portable location. So very, very compact, very robust, ideal for smaller setups to get where internet's not available, I suppose, and using that bonded cellular technology. Okay, let's keep moving. Okay, so the next step up from this is to use a fully integrated solution. So let's have a quick look at what that might be. So we can look at an all-in-one device. In this case, we're looking at the Digistor Engo. So this is an all-in-one portable encoder and transmitter. So this has got everything in the one box. It has the encoder, it has the modems, it has the antennas. So the live SDI input feeds directly into this unit. It has 6 4G modems inbuilt, All the antennas are built in there. It also has WAN connections and Wi-Fi, and we can bond between all of those. So it's ideal for fast deployment and setup. Applications like live news is very, very good, and also good for non-technical operators. Pretty much one button to push to get started. So there's no cables to connect. You just plug the camera directly in. Also includes a number of professional broadcast features, so very, very low latency, lowest possible latency. It's very robust and portable. We can see not a very good image, but this is the unit here. Typically, it's in a backpack. Ease of operation, as I mentioned earlier, very, very easy to operate, exceptional picture quality. And I suppose these types of units perform extremely well where there's very challenging bandwidth conditions. So if you're in situations where the cellular connectivity is particularly poor and there's lots of other people on cellular, with the 6 inbuilt modems and the technology it uses, very, very good connection. And also worth noting, it's a complete ecosystem. So it does include features like return video, talkback, and IFB, all in the one unit. Let's just have a quick look at the at how this unit works, very high level. We've got our live video feed coming in. In this case, it's depicted as a camera operator. It's feeding into the Digistor Encoder, which is then using Digisto's smart blending technology across multiple networks. In this picture, it's showing maybe you've got a satellite connection, you've got, in this case, 3 cellular modems, say 4G, you've got Wi-Fi, and you've also got cable modem. So it's bonding between all those, and it's being decoded by a waypoint device, a Digistor waypoint device, and fed into your production control system or remote monitoring. Also worth noting is that Digistor have a full ecosystem with a very sophisticated cloud portal to manage multiple incoming camera feeds. And they also have camera apps for iPhone, Android, etc. So it's a complete ecosystem. Sophisticated cloud portal, as I mentioned, enabling management of multiple incoming camera feeds, iOS and Android apps, so that you can effectively use that as a camera signal and go directly into the system from your phone. There's also apps for Windows and Mac OS. Digistor also have a very, very powerful internet gateway device or a router, which has 6 modems inbuilt. So it's a great system where you need your more professional features. Okay, just in summary, we really only touched on 3 use cases today, but the scope is pretty much unlimited. The use of those protocols like Srt and Zixi do make the delivery of very high quality, reliable video over the internet possible. As you would have seen, there's some very cost-effective options are available, which make it possible to cover events that would previously been cost prohibitive to recover. And certainly the use of 4G is becoming more popular, especially now that data costs for cellular connections are very affordable, and we'll start to see 5G come into the market as well. Certainly consider fully integrated solutions for that ease of operation and minimal setup. Okay, that's it from me now. I'll throw back to Mark, and we'll have a look at some of the Q&A.
Thanks very much, Andrew. That was a great rundown overview. There are a few questions, so a couple of them we should be able to answer live here. And the first couple were related to delays or latency when you're talking about the first case scenario, basically the point-to-point monitoring of remote video signals. Do you want to?
Yeah, I can answer that one. As we saw with the Digistor example, we can get down as low as 0.8 of a second, and that's really as low as you're going to get on that cellular type connection. With the first example with remote monitoring, there's a number of factors that come into it, I suppose. Certainly, the use of protocols like SRT, they're designed to deliver a reliable signal, so there is some delay inbuilt in that. So you might be looking at sort of throw a number out there. Maybe a 2-second delay would be typical. The second one here is How does Digistor compare with products like LiveView? Well, I suppose they operate in the same space. So similar sort of technology. Obviously, there are certain pros and cons. Certainly, Digistor has a very, very powerful ecosystem. Their cloud portal is very sophisticated, and but I'd certainly encourage you to contact Digistor, and we can talk through the relative differences between Digistor and LiveView. Okay, what is available for audio only? Multiple streams of audio. Well, certainly the products we've talked about today do have the capability to transmit audio along with the video signal. There are other sort of technologies, I suppose, that are available purely from an audio point of view, and we don't sort of have time to cover those today. If you have multiple Engos shooting the same with different shots, can you sync them? Generally speaking, the synchronization between the units, if the units are set up the same, there are settings within the Engo units, some of this other technology in terms of how you set the delay on those, and it's generally a trade-off between the lowest possible latency and the best network resiliency. So if all the units are set the same, then you can expect the feeds to be in sync. Okay, lots of questions coming in. How are we going for time, Mark?
Oh yeah, we're going good.
Okay, let's see what we've got here. What setup would you propose for remote producer involvement in a live editing session? Well, certainly that first use case would work in that environment. There are other technologies available which we can talk to you about, which are more might be more suitable in that case, where the producer would be able to join the signal from any location using any device, so maybe a laptop or an iPad or whatever it may be. The example we showed earlier on is very, very good for a point-to-point if the producer is always in a secondary location and the decoder's there, but probably not ideal if they're moving around. So there are other technologies that we have that would cater for that, Evelyn.
The next one from Dave's basically a comment. So
yes, well, certainly SRT can have very low latencies depending on network conditions, as low as 100 milliseconds plus a decoder delay. So thanks for that. Thanks for that, Dave. What bandwidth is required for full video streams? Well, this is really a trade-off between your quality requirements and bandwidth. Obviously, the higher bandwidth that you use, the higher quality you're going to get. If you have a lower bandwidth connection, you can still get a signal, but the quality is going to be less. And I gave some sort of indications early on. If you want very, very high quality, maybe because you're going to go on a critical viewing or projection screen, you might want 10 megabits per video stream. If you're happy with perhaps a low video quality, you can still get very, very good picture qualities if your video input is of high quality at 3 megabits or even lower per video stream. And certainly people are using rates lower than that as well. Okay, we're getting quite technical now. How many channels of embedded audio on the kiloview encoders for remote monitoring? I don't know that one. I'll have to pass on that one. We'll have to come back to you on that one. Okay, one from Andy here. Would the more complex setup that involves tele and talkback also allow for RS-232 over Ethernet traffic, for example, encoded head tracking data? I believe so. I believe so, Andy. There is options to transmit 232 data across that SD-WAN link. Would any of these setups be suitable for solo operators sending switched video audio? Absolutely, yeah, to YouTube. Absolutely. Certainly the encoders that we looked at there, they can be set up to deliver that signal directly to a CDN like a YouTube or a Vimeo. So the settings, the authentication settings can be entered directly into the encoder, and you would just plug in your video signal into that encoder, plug it into an internet connection or a cellular modem, bonded cellular modem, and you can stream directly to YouTube and Vimeo, and you can also add graphics and things as well. So that's very, very good question. Thanks, Paul. How do we calibrate monitoring? Okay, John, it's probably not quite in the scope of this one. KiloView E1 encoder is a sweet spot at about 8 megabit. Thank you very much, Dave. Dave's answering a lot of the questions for me, but he's suggesting 8 megabits is probably the sweet spot per video stream. Okay, and Chris is still on the line there. Can you share your screen with the Premiere Pro timeline through to the KiloView encoder, and then switch between outputting full screen and timeline? The KiloView one would take the video, takes a video output feed, so I'm not quite sure about that, Chris. I think the other cloud solution might be the better option for you, but happy to chat about that further. Okay, I think we've covered pretty much all the questions there for the moment. Back to you, Mark.
Okay, thank you, Andrew. That was great. We still have a couple of minutes if anyone wants to type in any additional questions. So just bear in mind that we can answer these questions anytime. You can get in touch by phone, email with us directly, and we'll come back to you if you want to specify more technical or detailed questions about your specific application areas. But it looks like we've got no more live questions coming in at the moment. So we might leave the question and answer for now and move on with a presentation. So I'd like to just thank you all very much for joining the event today. We're very grateful for your attendance and attention, and thank you specifically to Andrew Mooney for his overview presentation. As a reminder, you can see Digistor's contact details on the screen there, so please don't hesitate to contact us with any questions, advice, or assistance. As I mentioned, the conference was recorded, and the recording of a link to the recording will be sent to all the registrants in the coming days, so you will be welcome to share, review, and share with your colleagues. If we didn't get to any questions, and as they came in, we will get back to you. So expect that to happen in the coming days. But for now, that's all for the webinar, and we look forward to hearing from you in the future. Thank you very much.